Hi everybody, I'm Greg Fishel. Welcome to bonus weather video number 2 for this week, and we're going to be talking about clouds today and the fact that different types of clouds and different altitudes of clouds have differing effects on the Earth's temperature, and it's one of the big uncertainties as we move forward in terms of how is human activity going to change the amount and the type of cloud cover that we have out there. And again, this is one of the biggest wild cards in trying to predict what's going to happen in the future. So let's go on ahead and get started here. This isn't going to be a terribly long video, but here's my poor excuse for the ground, that little green elongated rectangle down there. And the clouds that exist closer to the Earth's surface, such as stratocumulus, stratus, cumulus clouds, they tend to have more of a reflective characteristic to them. In other words, incoming solar radiation is reflected off the tops of those clouds back into space. And so it actually makes the Earth cooler than it would be otherwise. And about 70%, believe it or not, of the planet is covered by some type of cloud cover at any one given time. And if you look at this picture here, and I'm sure you've all noticed this, or many of you have, is that you notice how the tops of the clouds here are bright white and then the underside is quite dark. Well, it makes sense in the sense that incoming solar radiation, which is visible to the human eye, is reflecting off the tops of these clouds, and it's illuminating them, okay, quite a bit. And so the brighter the surface, the whiter the surface, the more it's going to reflect. But underneath here, if the cloud's thick enough, then all that ultraviolet radiation cannot get through all those clouds, and so it's very, very dark on the underside of them, okay? So it really has to do with how thick the cloud happens to be. And then very high up, like 20, 25, 30,000 feet, you have cirrus clouds that instead of being made of water droplets are made of ice crystals. And these are fairly thin and wispy clouds. They have a very different look than clouds that are made of water. And so as a result, they're able to let a good bit of the incoming solar radiation right through them, okay? But as the Earth radiates heat back to space, and we do that at a much, or the Earth, not we, the Earth does it at a much longer wavelength, and we call that infrared radiation as opposed to the ultraviolet, which is coming in from the sun. It traps that outgoing infrared radiation and sends a portion of it, not all of it, but a portion of it, back toward the Earth. So generally, the higher the clouds and the colder the clouds, the more of a warming effect it has due to absorption. So this is just a graphical way of illustrating that. The lower clouds do more reflecting, causing cooling, and the higher clouds are more about absorption, and they tend to warm the planet, at least to some degree. The overall net effect, though, of all the clouds around the Earth is to cool the Earth and not to warm it. So the reflection dominates over the absorption. Okay, so in general, this not trying to be redundant here, but just summing up, the lower the clouds are in the atmosphere, the greater the cooling effect due to reflection, and the higher the clouds are in the atmosphere, the greater the warming effect due to absorption. Now, here are a few additional facts that are somewhat interesting, at least I hope you find them interesting. The overall effect of clouds, at least for now, is to make our planet cooler than it would otherwise be. And the one interesting thing about clouds is you need particles in order for those clouds to form. We call these particles condensation nuclei. It's very, very difficult for water droplets or ice crystals to form without those particles being present. Well, because of the industrial activity of the planet, we are adding particles to the atmosphere every day. And so then the question becomes, are we going to create more cloud cover as a result of that? And could that slow down the increase in temperature that we're going to experience by the emission of CO2 and methane and nitrous oxide and all of that into the atmosphere? Well, it depends on what type of cloud it is and how high up in the atmosphere it is. If we produce more cirrus clouds, okay, then that would actually warm the planet, accelerate the warming. If we produce more low-level clouds, then that would increase reflection of incoming solar radiation back to space, and that would slow down the amount of warming. And this is really one of the big wild cards right now in climate science itself. So how will the overall effect of clouds change as man continues to emit more particles into the atmosphere. Again, this is one of the biggest uncertainties in climate science and one of the biggest sources of uncertainty regarding any future temperature increases. And the thing about it is, there's always uncertainty in science, and sometimes the television industry is reluctant to admit that, okay? Like when it comes to just general weather forecasting, I remember I had some television consultants one time tell me, never, ever talk about something you're not sure of, okay? Well, I found by talking to the general public that they felt exactly the opposite, okay? Is that they wanted to know when there was uncertainty in a forecast, because that way, you know, let's say they had plans for the weekend, and right now on a Tuesday, the forecast is for there to be a lot of thunderstorm activity. But if they know the confidence level in that forecast is low, then they're going to hold out hope for things to change. If the confidence level is high, then they probably need to make some alternate plans. So that's useful information. And, you know, for the first time in human history, now with computer models and so forth, we can actually quantify the amount of uncertainty in a forecast, and we can do the same thing with climate science, okay? So when you hear a range of temperature predictions over the next 100 years, like maybe 2 to 9 degrees, you're sitting there thinking, oh, they don't know what the heck they're talking about, okay? Well, the thing is, we do know what the heck we're talking about, but we're also honest enough to admit that there are a lot of uncertainties in these calculations, okay? So if it ends up being 2 degrees, we can probably adapt with no problem. If it ends up being 9, then that would be catastrophic to the planet. And so, as I have said many, many times, and another example is relating this to tornadoes, even at the highest level of alert, okay, like a level 5 out of 5, and you're certain there are going to be damaging tornadoes somewhere, the thing about it is the chance of it coming over your house is very, very small. But there is such a thing as low probability, high impact, okay? Where if it does and you're not prepared for it, you're toast, okay? So the question is, do you want to play Russian roulette and simply say, well, the odds are in my favor, I'm not going to do anything to plan for it, and then that 5% probability comes true, the tornado goes right over your house, and you're not prepared and you lose your life, okay? It's the same thing with climate, is that it could turn out to be 2 degrees, and it could be something we can adapt to very, very easily. But if it turns out to be 9 degrees and we're not prepared for it, then we are toast, okay? So this is one of those important things to realize, that there is uncertainty. We have to admit that there's uncertainty, and we have to do everything we can in our science to reduce that uncertainty. And so by doing so, then people would be more confident in the action that they're taking. But sometimes people use uncertainty as an excuse to do nothing, and that's not a good idea. All right, folks, that's it for now. That is bonus weather video number 2 for this week. Number 3 will be coming up Friday, and the next daily weather update, of course, coming up tomorrow. You all take care, folks, and we'll talk to you soon. See you later.